In this question, we're going to solve trigonometric equations which are reducible to quadratic equations. During the operation, we'll use the trigonometric identities. Part A. 2 sine squared x minus 5 cosine x is equal to 4. This equation involves two kinds of trigonometric ratios, sine and cosine. The first step in solving such kind of problems is to make only one kind of ratios left. One commonly used technique is the trigonometric identities. In this case, we convert sine squared x to 1 minus cosine squared x to make only the cosine ratio left. Then we've got the quadratic equations involving cosine x. Factorize it. We've got cosine x is equal to negative 1 over 2 or negative 2. Cosine x is equal to negative 2 should be rejected because for any angle x, the value of cosine x should be between negative 1 and 1. Therefore, cosine x equals negative 2 has no solutions. So we'll focus on cosine x equals negative 1 over 2, which is less than 0. For cosine x being less than 0, x lies in quadrant 2 or quadrant 3, and the reference angle is 60 degrees. Therefore, x equals 180 degrees minus 60 degrees or 180 degrees plus 60 degrees. That is 120 degrees or 240 degrees. That's it for part A. Part B, we need to solve the equation tangent x equals cosine x. Similar to part A, there are two kinds of trigonometric ratios in the equation, tangent and cosine. As said, we should try to make it only one kind left. Let's see what we can do. We know that tangent x is equal to sine x over cosine x. Note that cosine x is not equal to 0, otherwise tangent x is not defined. We can multiply both sides by cosine x to get sine x is equal to cosine squared x. Again, we'll have to keep only one kind of ratios left in the equation. Convert cosine squared x into 1 minus sine squared x, and again we've got the quadratic equation. This time we may not factorize it easily. Then let's use the quadratic formula to find the possible values of sine x. This result should be rejected because it's less than negative 1. After that, use a calculator to find out the reference angle, determine the quadrants in which x lies. We've got x is equal to 38.2 degrees or 141.8 degrees, correct to the nearest 0.1 degree. That's it.